Hello and welcome to T1 Day 26 of Honors Precalculus. We're going to continue with our journey of graphing trig functions, and now we really get to the ultimate awesome, which is the super general form of each of them. So the super general form of each of them are below and highlighted, or whatever you're looking at right now. So the key is now we have a coefficient A, B, we have that constant C, and we have that constant D in each of them. What do each of them do? Well, A right there is going to tell us the amplitude, and it's going to be the absolute value. So the amplitude is always positive. It's the distance from the midline to the max or min. The midline is going to be y equals d. Y equals d in both cases. And the period is going to be 2 pi over b. 2 pi over b. Now the horizontal shift, this is key here. And you get the dog playing with a toy in the background as your mid-video entertainment. Your horizontal shift is going to be c. Horizontal shift is going to be c, and it's going to be c units to the right. So if you subtract pi over 2, you go 2 to the right. Subtract a negative, you go 2 to the left. But this is the super summary right here. The thing I really want to point out is in the middle of these right here, you'll notice that it says b times theta minus c. That's the form it has to be in. So you have to factor out on the inside the b. The b has to be all by itself in front of the theta minus c. That results in a form that gives you these four things right here. Super important. So if we use this information to graph -4 sine 4 theta plus 2, let's put it all together. The first thing it tells us, and I like starting here, is the midline is at 2. So let's put 2 right here, put 2 right here. So let's make that midline right here, y equals 2. And the period of this, the period, is going to be 2 pi over 4 right there. So the period is going to be pi over 2. So it's going to repeat every pi over 2. So let's put pi over 2 right here, and we'll make this pi right here. So that means it's going to go one rotation every period. And then the amplitude is 4, so it's going to go, amplitude is 4 right there, so it's going to go up 4 and down 4. So it'll go up to 6, 2, 3, 4, 5, 6, call that 6. So this is as high as it'll go right here. And as low as it'll go, 2, 4, 6. It'll go down right here to y equals -2 and y equals 6. That's the max and min. So we know it's going to be bound between those things. And this is sine. Sine of 0 is 0. And then it's going to be stretched. So sine of 0 is 0, 0 plus 2. So it's going to start here. And instead of going up, it's going to go down. So we know it's going to repeat itself like this. And we know that it's going to do a full rotation each period. So it's going to go this to this to this. And we know that it's one rotation like this repeated. So what you can do is you can just keep on doing the same. Oops, sorry. Goes down to here immediately, sorry. It goes up, up, and then back down. So then it's the same curve. And the key, or the helpful thing, is you can just keep on. Oops. Ooh, I'm doing terrible at curves today. This is a good example of how you just slow down on your curve. And also draw in those dots first. It's the same shape over and over again. So you can copy and paste it right there. So once you get your first oscillation like this, you can just copy it over again. So what about this one? This is slightly different. This is cosine. But again, we start with our midline, which is at 1. So let's put it at 1 right here. So this is our midline. Y equals 1. Just like this. And then we know the amplitude is 3. So it's going to go up to 4. So its max is going to be here. And the min will be y equals -2 down 2, because the amplitude on this is 3. Now the period is going to be 2 pi over the b value, which is just going to be 2. So in this case, the amplitude is pi. So let's just make this pi and this 2 pi. So we know it's going to start cosine. When you have it at 0 here, you also have to keep in mind that this right here means it's pi over 4 to the right. So cosine usually starts at 0, 1 at the top. So now we know it's going to start 3 up from that, and pi over 4 to the right. It's going to start 3 up from that and pi over 4 to the right. It's 3 up because of the stretch, and it's pi over 4 because of that. Now cosine just goes down first, so we know it's going to look like this. There's one rotation right there, so it's going to go down and up, so there's one oscillation. So you literally just do the same thing again. It's going to go down like this, and then down. Again, draw those points. I was about to do it without drawing the points, and as we saw in the last example, that's not the best idea. So then you end up with this curve right here. The key thing to start with is that point right there, and that's because it's 3 up and pi over 4 to the right, based on the information right there. So this next example is a little bit more involved because the internal part here is not quite in the right form. You need to turn that into cosecant of pi over 3 times x plus 1. You have to factor it out and then plus 2. We know that the midline is going to be this plus 2, so let's put that at 2 right here. So we know that there's going to be a midline at 2, and the amplitude is going to be 3. So cosine of it's going to go up to 3, so we'll go up to 5 here. And we know that cosecant is going to be outside of that, so we go 3 down here to y equals -1 and y equals 5. Cosine is that cosecant, excuse me, is the u shape going up. So what does this mean? Well, let's do the period first. The period is going to be 2 pi over 3, which is 2 pi times 3 over pi, which is 6. So the period is 6. It's going to repeat itself every 6. But then this right here means pi over 3, it's going to be a shift, but it's not pi over 3 because you have to do it after you factor. It's that one right there. It's the 1. So you have to factor out the pi over 3 first, and it's going to be 1 to the left, 1 to the left. So if you remember your cosecant graph, there's usually a vertical asymptote at y equals 0. So x equals 0. So now it's going to be, if we make this 6, 1, 2, 3, 4, 5, 6 right here, it means that the vertical asymptote is going to be x equals -1 instead of 0. And it's going to be, oh, that's not a very good vertical line here, x equals 5. Here, vertical asymptote, it's usually at 1 and the period, which would be 0 in the period, 0 and 6. But in this case, it's -1 to 5 because of this shift left 1. So what does this mean? Well, this means that you're going to have this U shape that repeats itself. There's also a vertical asymptote at pi over halfway between. So halfway between is x equals 2. So you're going to have these U shapes in between. So it's going to go up here. It starts up, and then the next one goes down. The next one goes down right here. It alternates up, and then down, and then up, and then down. There's another one right here. And the way you get that is, again, it shifted 1 to the left. You got to remember what the base graph of this looks like. So what does cosecant look like? You need to memorize that so you can shift it. So we're back to Ferris wheel land here. So what's going on here is if you graph what's going on here, in this case, the person is boarding at 10, and then it's turning continuously. So it's going to go up and then down back to 10. Now the max height here, the max height is going to be 560 because the wheel is 550 and you start at 10, and it takes 30 minutes to go all the way around. You also know the midline is going to be halfway between, so that's going to be 285. So now when it asks the equation, you know it's going to, the height, and we'll call it h of t, the height h of t is going to be something plus 285. Well, the amplitude of this is 275, because that's the distance from here to here, 275. So there's going to be a 275 out front. And then which function do we want to use? Well, let's use cosine. So if we use cosine here, cosine usually starts here and goes down, but this one starts here and goes up. So we're going to reflect it. So it's going to be negative 275 cosine. And then the question is, what's the period? Well, the period on this is 30 minutes. And we know that period is equal to 2 pi over b. So if that's true, we know that 30 is equal to 2 pi over b. What does that mean? It means that b is equal to 2 pi over 30, which is pi over 15. So that's our b value, which is the coefficient of the t. So it's pi over 15 times t. So this would be the equation right here. And then state how high off the ground you'll be after riding the wheel for 8 minutes. You literally just plug in 8. So h of 8 in this case, and you plug it in your calculator, you're going to get 313.745 feet right there. So if you do the exact same type of work on this one, it gives you enough information right here to figure out what the equation is going to be, which will be negative 50 cosine of 2 pi over 5t plus 50. And you get that information from things like the fact that you start at the 6 o'clock position, so there's no, you're starting at 6, which is straight down, so it starts on the ground, and it's 100 feet high, so the midline will be at 50. And the period is 5 minutes. The period is 5 minutes. One revolution is 5 minutes, so you have to find the b value. So that would be 5 is equal to 2 pi over b. So that means that b is equal to 2 pi over 5. So that's where that comes from. And then it's a similar type of shape that we did before, but it starts at 0, so it's going to be negative 50 cosine. And then you fill in the table and you get that table. So this just takes practice, but if you look at the general form at the beginning, it should fall into place. Now here's another one, but you have a 450-foot Ferris wheel and a 10-foot platform and a 12-minute revolution. Use a different color there. 12-minute revolution. Find an equation. So what does this look like? And you start at the 9 o'clock position, meaning you're going to start not at the bottom, you're going to start halfway. You're going to start at the equilibrium. So the base of this one is 10, and it's going to go all the way up to 460 because you know it's 460 because it's 450 all the way up. So the midline is going to be at 235, and 9 o'clock position means it's going to start at here. It's going to start at the equilibrium point, and then you're going to go counterclockwise. So you're going to go down, up, and down. So what is the period here? Well, you know that 12 has to be 2 pi over the b value. So b is going to be 2 pi over 12, which is pi over 6. So that's the coefficient of theta. So h of t in this case, and this is just like the sine function but flipped over. So it's going to be negative the amplitude sine of pi over 6 theta plus 235, which is the midline. So the midline was right there. That's where you get the b, and this is like sine. Sine usually goes up and down like this, so to get it to do that shape, you have to flip it over. And now if you want more practice, we can do this in class if you want to ask about it, or you can do it on your own. More practice right there.